Hi, my name is Anna, and I'll be giving this talk today on behalf of my co-authors about this study that we called Shoreline Responses to 100 Years of Coastal Interventions, case study of Letitia Spit, New South Wales, Australia. So it's important to start saying that this study is part of a bigger project that investigates the natural sand bypassing around Fingal Head. Fingal Head is located on the south limit of Letitia Spit, which is just by the border between New South Wales and Queensland. This region, from southern Gold Coast to Tweed Heads, has a long-term history of coastal management. And in this context, the historical analysis of the neighboring downdrift and updrift areas of Fingal Head, it's important not only to identify the contribution of the natural bypassing to the sediment balance, but also to verify if there is any influence of the coastal interventions on the bypassing process. With this idea in mind, we have published recently a study that provides a brief morphodynamic analysis of the changes that happened in the last 90 years between North Letitia and Kira. Now we want to move south, and in this talk we'll be exploring the shoreline variability between North Letitia Spit and Fingal. Another relevant motivation to this analysis is the growing concern from community that observes significant changes in the coastline after the artificial sand bypassing system has started to pump sand from North Letitia to southern Gold Coast. And more importantly, they are worried that this erosive trend will keep going in the future. Before I go forward into methods and results, let's take a brief look into three important coastal interventions that happened in our study region. In the late 1800s, the construction of the Tweed River training walls provided a structure to Letitia Spit fixation. Later, in the 1960s, the extension of these training walls caused the obstruction of the northward sediment transport, leading to severe erosion of the Gold Coast beaches. After 4 decades and several measures trying to restore the sediment balance, an artificial sand bypassing system was installed, solving the chronic erosion of Gold Coast, but causing some changes in Letitia Spit. To understand the long-term variability of Letitia Spit, we have used the imagery dataset that has 384 individual days covering the period from 1930 to 2020. The aerial photographs and Google Earth images were rectified and presented a very low position error of about 2 meters on average. The other satellite images were rectified by the provider and present on average 4 meters of position error. After this, we started mapping the wet-dry shoreline and the dune vegetation base. The variability of the shoreline position was obtained using the digital shoreline analysis system. As we are using images from several sources and it's not possible to have the time that these images were acquired, we calculated the horizontal tide excursion considering the beach slope and the local tidal range. And the error was about 42 meters on average for the whole beach extension. Another error to be accounted for in the mapping is the pixel resolution. That is, in general, good, besides for the Landsat images that have a resolution of 30 meters. Trying to minimize the influence of these errors in our interpretation, we have added as much individual images as possible so we can have more confidence on the trends that we are observing. We also have compared the results between the satellite images and the aerial photographs that have a better pixel resolution. And we analyzed the time series and verified the occurrence of some spikes, and if they had a reason to occur or if it was just a mapping error. Next steps in this analysis is compare shoreline results with topobathymetric surveys and with the results obtained by the automated analysis done using CoastSat. Also, we have mapped the sandbar positions, and we'll be adding this to our interpretations in the future. Here in these graphs, we are showing the difference between maximum offshore and onshore position of the shoreline and dunes on each profile. For the central and north region, we observe large changes in position for both dunes and shoreline. But as we move south towards Fingal, and especially for the dunes indicator, the maximum difference in position was about 50 meters for a period of 90 years. Therefore, we do not consider that the dunes around Fingal and Dreamtime presented any significant trend, and excluding possible errors, any significant retraction or accretion, it was most likely related to a natural event than a response to the coastal interventions. Looking to accreted and eroded areas, between 1930 and 2020, Letitia Spit gained a beach area of 300,000 meters square and about 580,000 meters square for the dunes. This accretion was even bigger until the 2000s when we observed the maximum offshore extension presented here with the red line in the graphs. Between 2000 and 2020, around 200,000 meters square of the dunes and beach was eroded. If we calculate some general rates considering the 70 years from 1930 to 2000, we obtain a beach accretion of 7,000 meters square per year, which means basically one soccer field per year, and 11,400 meters square per year of accretion for the dunes. The erosion in the last 20 years had a rate of around 10,000 meters square per year. So if this erosion trend was persistent, we would expect another 30 to 50 years for both shoreline and dunes to return to the 1930s position. But this is not exactly what is happening. Let's take a look in the shoreline position series. In the northern limit of Letitia Spit, a 200-meter shoreline progradation after the extension of the training walls occurred in around 10 years. After 2001, about 100 meters of erosion happened in around 2 years. And after that, we see a mean shoreline position kind of stabilized. Then, 500 meters south, 2 decades were necessary for the shoreline reach 200 meters of progradation. And while after 2001, it was about 5 years for 100 meters of beach erosion. Then, another 500 meters south, we have about 3 decades necessary for shoreline finally reach 200 meters progradation, and about a decade after 2001 to reach 100 meters erosion. And finally, in the fourth section, almost in Fingal, we also took around 3 to 4 decades to accrete 107 meters. The erosion trend after the commencement of the bypassing system, however, just reached the region around 2004, and the maximum erosion happened around 2011-2012. Since then, the trends started to show some shoreline progradation, which tends to move all the way north. Dunes had a very similar behavior. In the northern limit of Letitia Spit, 600 meters of dune progradation happened between 1930s and mid-1990s. After 2001, 5 years of erosion trend moved the dunes back 100 meters, and then kind of stabilized position. Then, in the second sector, 500 meters of progradation happened from 1930s to mid-1990s, while after 2001, 100 meters of dunes were eroded in 10 years. Third sector, dune accretion was started around the 1960s and took about 3 decades to reach 200 meters progradation. The erosion after 2001 took 15 years to retreat 100 meters of the dunes, and it seems to have a slight erosive trend still in place. The fourth section had a dune accretion of 180 meters in 3 decades and 70 meters of erosion from 2009 to 2015. Now, it seems to be stable to a slight accretion, kind of in the same manner that we observed in the shoreline indicator. Finally, let's take a look in Fingal and the natural bypassing. First, this figure shows the shoreline position variability using a color scale from green to red that suggests accretion to erosion along the last 2 decades, which is in the vertical axis, in each profile along the study area, which is in the horizontal axis. So, we just saw that the erosion trend triggered by the Tweed artificial bypassing in 2001 was only approaching Fingal around 2011-2012. Here we also observe an erosive condition of dream time during the previous years. And with the occurrence of Tropical Cyclone Oswald in January 2013, a severe shoreline retraction occurred in Fingal Beach. In the next 7 years, this erosion slug, if we can call it like that, moved north. So erosion observed in Letitia Spit throughout the last decade, it's already part of a natural event. More importantly, it's being followed by a accretion slug that is spreading towards north. The occurrence of some tropical cyclones like Debbie and Oma, differently from Oswald, supported large sand bypassing around Fingal Head through a sandbar system. And this provided the sediment input for Letitia Spit in the last years. Moreover, if we look into the long-term change in this profile in Fingal, we can observe that the last decade variations have been happening in decadal cycles for at least last 30 years. From this, we presume that the natural bypassing in Fingal has direct relation with large-scale climate drivers, and of course, with the wave direction changes. As final remarks for this presentation, we need to keep in mind that perception is something important for the coastal management. Local community perception tends to go no much longer than 30 to 50 years. In this case, they knew a largely accreted beach, and the erosion that happened after the artificial bypassing started has a different proportion than if we look into the shoreline changes over a longer period. With our analysis, we recognize the erosion in the early 2000s, but we can observe that the coastline is yet in an accreted and balanced condition. In terms of shoreline and dunes responses, we could note that for a beach extension of about 3.5 kilometers, the shoreline changes related to coastal interventions that happened in the downdrift end of the beach took decades to almost reach the other end. Also, we observed that the erosion migration moves about twice faster along the beach extension than the accretion migration, and that over the last decade, Letitia Spit is mostly responding and adjusting to natural events instead of being under a chronic erosive state. For the bypassing, we can conclude that the coastal interventions didn't get to interfere much in the process, and the natural bypassing here responds to decadal large-scale drivers. Also, over last years, Letitia Spit has been receiving great sediment input, facilitated by some tropical cyclones and storms that triggered large bypassing pulses. So thank you all for your attention, and if you have any comments or questions, please contact me through the email below.